The universe is a vast, dynamic world full of beauty and energy. Galaxies collide, stars explode, and life flourishes on countless planets. But what does the universe have in store for the distant future? What is its ultimate end? Today we delve into a grim but fascinating concept: the heat death of the universe. Supernova explosions are beautiful, they allow something new to emerge. But today we're going to talk about the heat death of the universe. Heat death is a hypothetical future scenario in which the universe reaches a state of maximum entropy. Entropy is a measure of disorder in a system. Imagine this: if you leave a cup of hot coffee on the table, it will gradually cool down. The heat dissipates into the environment and energy becomes less available to do work. The same thing happens in the universe, only on a much larger scale. Eventually, all stars will burn out, and the gas reserves for the formation of new stars will run out. Black holes will gradually vaporize, and matter will decay into elementary particles evenly distributed throughout the expanding space. The temperature in the universe will approach absolute zero, and there will be no energy sources left to sustain any processes. Everything will come to a state of maximum indifference. You're about to see what de-sitter space would look like. But even in a state of heat death, there will still be a small amount of energy associated with dark energy in the universe. Dark energy causes the universe to expand at an accelerating rate. Eventually, the universe will become what is known as de-sitter space, a perfectly homogeneous, infinitely expanding space with nothing but vacuum. It would seem that nothing else can happen in de-sitter space. But even in absolute vacuum there are quantum fluctuations, spontaneous and short-term appearances of particle and antiparticle pairs. These fluctuations are a fundamental property of quantum mechanics. Theoretically, quantum fluctuations can lead to the formation of new universes. In very rare cases, the fluctuation could be large enough to create a false vacuum that would begin to expand at a tremendous rate, giving rise to a new universe completely different from our own. But what does this mean for us, for humanity? If the universe is doomed to heat death, and even after that new universes can arise, does our life repeat itself again and again? Here we come to the concept of eternal return proposed by the German philosopher Friedrich Nietzsche. Nietzsche assumed that the universe is finite and time is infinite. Consequently, all events that happened in the past will inevitably repeat themselves in the future, exactly the same. Imagine living your life over and over again, with the same joys, sorrows, successes and failures. How would you feel knowing that it would happen again countless times? In the context of heat death, eternal return takes on new meaning. Even if our universe is doomed to extinction, the possibility of new universes emerging from quantum fluctuations offers hope that life and consciousness can be reborn again. Perhaps somewhere in the distant future, in another universe, an Earth-like planet will reappear, and life, and perhaps even ourselves, will reappear on it. Indeed, the thought of eternal return may cause discomfort or even absurd bewilderment. However, putting aside the fear of endless repetition, this concept encourages us to rethink deeply. It emphasizes the value of each moment as our every action, every thought, every emotion takes on the weight of eternity. Understanding this makes us think about our place in the universe, what role we play in this grand cosmic dance, and most importantly, how we live our lives with meaning and awareness. The heat death of the universe is a grim but inevitable finale. But even in this darkness there is room for hope, for reflection on the eternal return and the endless cycle of birth and death. By exploring the most fundamental questions about the universe, we better understand ourselves and our place in this vast and mysterious world.